So let us do now the voltage divider bias. So you know the voltage divider bias circuit is so you have a transistor here, and then you have a resistance RE here, and this is your grounded here, and this time we are applying AC signal here. These questions are very simple. Okay, just you have to draw the equivalent model circuit. So here a transistor is given. Say this is C2, this is C1, or say this is C3, this is C1. Okay, and here you have transistor C2, and here you want to measure the voltage, and here the current is coming I0. Everything is same. Okay, and here the input current I is coming. So the first step is, so these resistance are divider circuit. So these resistance are R1, R2. You can take the beta. Okay. So the first, I'm not doing a numerical problem. Okay. In numerical problem, you have to solve the DC, you have to do DC analysis first, and you have to calculate IE in the circuit. Okay. And once you know, find the first step is DC, perform DC analysis. First is DC analysis, and find IE, and then calculate RE, which is 26 millivolt upon IE. Okay, so this is the first job. Now I'm doing AC analysis here. And AC analysis, what is the first step? The first step is, what is first step for AC analysis? The first step is make VCC ground, and this is short circuit because this is the AC analysis. Capacitor will be short. DC analysis, capacitor open. This is short. Okay. Now once I short this one, what will happen to RE? Tell me. What will happen to RE? If I short this one, what will happen to RE?
No current will pass through RE.
No current will pass through. That means RE also gets shorted. Okay. So that is a difference between. So there may be transistor and capacitor. There may not be capacitor. Both the case, the analysis will be different. Now here capacitor was there. So as soon as you make short, this is disappeared. So there is no resistance now. So this is a simple short circuit. It was a simple short circuit. It is grounded. Okay.
The screen is blur. और video भटक रहा है.
Screen is blurred.
No, sir, clear.
Clear. Okay. So now this becomes short circuited. Now you have to do AC analysis. Now this resistance is connected to base and ground. Similarly, this resistance also connected to base and ground. Okay. Now let me make the circuit. So now this will be your R1. This is your R1. This is your R2. Okay. And I'm replacing this junction by a resistance called beta Re. Okay. So let me replace this by beta Re. Okay. Now here this is grounded, so I can directly separate this output also. Otherwise if this is the resistance there, then you cannot separate this one. Okay. Now what is there? Now this is your IC coming, beta AB coming here. Okay. So I can make this beta AB separate because this is grounded. Okay. So now this will be a beta AB, and here can you see? And here you have a RC, and if you want you can put if you want to put R0, you can put R0, the output resistance, and otherwise you can make that also infinite. So this is your R0, and you have RC also, RC. Okay. And this is your beta IB current. Can you see that one clearly? This is RC. Okay, this is RC and this is your R naught. So this is the equivalent circuit. And RC, the current is coming from ground here, I naught. So here I naught current is coming. Here in this resistance, how much current is coming? How much current is coming in this resistance?
IB.
IB, very good. Okay, so I am putting IB current is coming here. Okay, and it's going to the ground. Now you can solve this circuit. Okay, you can find the parameters. Okay, so I am interested in 4 parameter. Number 1 is your Z impedance. Z impedance, what you do, you make all circuit open, you make it open. Okay, so now, so earlier case you was having here what? You are having here only RB. Last कल जो किया था. Now you have R1 R2. So you can, what you can do, you can replace this R1 R2 by a resistance called R dash, because both are parallel. So you can replace this by R dash, where you can say my R dash is equals to R1 R2 and R1 plus R2. That is the thing you can do here. Okay, now this is R dash, this is the beta RE. Okay, this is the parallel. So this is your Z impedance. We measure Z impedance here. Z impedance will be a simply parallel R dash and beta RE. Okay, now you want to find the second, your output impedance Z0. Okay, so Z0 will be what? Z0 is simply you're measuring out across RC. So you want it Z0. Okay, so Z0 is what? Z0, you make this output terminals. Okay, output terminals with the resistance. So RC R0 parallel. Okay, so you have a R0 parallel to RC. Okay, in general R0 is infinite, is very large compared to RC. So this you can write only equals to RC also. Similarly here R dash is very high. So it's, if R dash is very high compared to beta RE, then this is parallel combination. This also you can write simply beta RE. Okay, so for that you have to see the question, what are the values are coming. Okay, so that time you can replace. If they're comparable, then don't replace. If they are very high the difference, then you can neglect the other one. Okay, and the third thing, what we want AV, that is V naught upon V input. Okay, now here this is my I input current that we'll see later. Okay, so this is your R dash beta RE. Okay, so V naught is again simple. V naught is what? I naught RC. V naught is your I naught RC. Okay, either you write I naught RC or you can simply write beta IB current is coming through these two resistance. Okay, so your V naught will be minus beta IB, like we had done yesterday, R naught parallel to RC, total resistance into total current. Total resistance, equivalent resistance 1, and then from this resistance beta IB current is coming. So this is a V output, and V input is very simple. V input is what? V input is here. This is IB beta RE.
IB beta
RE. So your AB will be now what? Minus beta IB R naught RC upon IB beta RE. Okay, IB cancel, beta cancel. Now your test will be minus R naught RC RE. Okay, and that V naught you can also write. Okay, if this R naught is very high, then you can simply put R minus RC upon RE. Is visible or not visible? Okay, so if so, your AB is, I'm writing again here, minus R naught parallel to RC upon RE. Okay, if R naught is greater than RC, then your AB will be simply minus RC upon RE. Okay. Now the third thing is you need to calculate your current gain. Okay. So current gain also very simple. You need to find I.
एक क्वेश्चन है, हम ऐसे दो मतलब इनपुट साइड का और आउटपुट साइड का सर्किट जो है वो सेपरेट क्यों कर रहे हैं?
भी मॉडल है, ओके मॉडल है, इससे एनालिसिस आसान हो जाता है, ओके अदरवाइज एक मॉडल नहीं है तो फिर सॉल्व एसी के लिए सॉल्व करना मुश्किल पड़ता है। और वैसे हमने मॉडल बना के हम देखा तो दोनों इक्वल, दोनों सेपरेट हो ही रहे हैं ना, जब सेपरेट हो ही रहे हैं तो सेपरेट कर दिया हमने उसको, ठीक है। जब अब ये इनपुट अलग हो गया, आउटपुट अलग हो गया, एनालिसिस बिकम सिंपल सिंपल, ओके अदरवाइज थिंग्स विल बी कॉम्प्लिकेटेड। सो
लेकिन वो कनेक्टेड होंगे ना, बेस एमिटर
अरे
है तो।
अरे तभी तो मॉडल दिया है, तभी तो मॉडल देख के सॉल्व करते हैं, वरना वरना तो आप डायोड को भी सॉल्व नहीं कर सकते हो बिना मॉडल के। तो बी कांस्टेंट वोल्टेज मॉडल किया था हम लोगों ने, नहीं वो एक्चुअली थोड़ी होता है, तो वो तो सिंप्लीफिकेशन है। आर यू गेटिंग दैट पॉइंट? वरना के सॉल्व कैसे करेंगे? नॉट डायोड we are replacing junction with a resistance, that is also not true, but this is an approximate analysis, okay, we're using the model. So this is your AV, but this is almost true, okay. Now you want gain, AI, AC or current gain or AI, and it is I naught upon I input, okay. And I input, you know what is I input? कितना होगा I input बताओ, कल निकाला था कितना होगा I input? Total current, total resistance, okay, IB. So it will be IB, okay, IB upon what? Tell me, R dash and R dash plus beta RE. Can you write like this? Can I write like this? I input. Anyone tell me? Can I write like this? R dash. Yes or no?
Yes, sir.
Because if you want IB, total current into, if you want IB, then total current into this R dash divided by sum of resistance. Okay. And
सर डिनोमिनेटर में बीटा आरी भी आएगा ना, आर डैश इंटू बीटा आरी।
तो लिखा है ना मैंने, R dash plus बीटा लिखा है ना, वो IB के AI के डिनोमिनेटर में आएगा ना, मैंने तो A इनपुट उल्टा लिखा है ना, इसको रिवर्स लिखा है ना।
कभी भी पैरेलल का कंपोनेंट आता है ना, मल्टीप्लिकेशन, आर डैश इंटू बीटा आरी आएगा ना डिनोमिनेटर में।
इस करंट डिवीजन लगा रहा हूँ मैं, करंट डिवीजन में सम करते हैं, पहले थोड़ी करते हैं।
सॉरी सॉरी सर।
पता नहीं 50 से ज्यादा सवाल कर चुके हैं हम, एक ही चीज, तुम लोगों को कंफ्यूजन पता नहीं क्यों दुनिया होता है, अच्छे से फोकस करके देखते नहीं उसको क्लास के बाद में। ओके नाउ I naught, okay, how can I write I naught? Tell me.
Beta IB.
So I naught will be your beta IB. Very good. Then R naught RC, yes or no? And R naught, okay, because if you want beta IB is total, beta IB is total current, na?
Beta IB into R naught upon
Beta IB is total current, so I naught will be beta IB into R naught upon R naught plus
RC.
RC. Very good. Okay. Now you want gain AC. I naught is your beta IB into R naught plus RC. Then you have a IB R dash plus beta RE. Okay. Divide by na upon R dash. So solve. Tell me what is coming. What is coming? So your AC will come. Okay. Beta IB. Okay. R naught upon R naught plus RC into R dash upon, okay, IB तो cancel हो गया ना, R dash plus beta RE. Okay, now I'm removing this circuit, I don't need this, okay, because we have done all the things. Now you can simplify. If is R naught is greater than RC and R dash is greater than beta RE, then your AC will become what? Beta R naught, almost R naught, R dash cancel. So your AC is again almost beta, the current gain. तो सर्किट सारे सेम ही है, तरीका सबका एक ही है। अब बस हमने फॉर्मूले लिखे हैं, एग्जाम में क्वेश्चन आएगा तो वैल्यूज दे रखी होगी, आपको वैल्यूज को पुट करना है और आंसर निकालना है। अब इतना चारों सब एक साथ नहीं पूछेगा, दे विल आस्क ओनली 1 or 2 क्वेश्चंस। दे आर आइदर इनपुट इंपेडेंस, दे विल आस्क, अदर दे विल आस्क व्हाट इज द वोल्टेज गेन और करंट गेन और आउटपुट इंपेडेंस। ओके, so yeah, then you can do it, you can solve quickly. Okay, so this is your voltage divider bias. Okay, now before I do the exam problem, I want to do one more circuit of voltage divider, which is slightly different than what we have done right now. Okay, so let us do that one. Now, if there is no capacitor in the circuit, okay, in the RE, then then your calculations will change. Okay, so let us do now. This is, you see carefully, okay, because don't do mistake in the exam. Okay, so you have this R1, and then you have a R2, and then you have a this base. Here you have a RC. Somebody mic is on, and then you have a RE. Okay, and these are grounded, and here you have a capacitor C1, V input, RC plus VCC. Okay, and here you have again a capacitor C2, and here you are applying, measuring V output. I naught current is coming here. Okay, now DC analysis we do as usual. Okay, now AC analysis, you see here no capacitor, here capacitor is not there. So now this you cannot short circuit. Okay, so once you cannot short circuit this one, your equivalent circuit will also change. Okay, now because now IC is not going to ground, because equivalent circuit, this IC should go ground. Okay, but now your resistance is there, so this should go through the resistance only. So let me now draw the equivalent circuit of this one. Okay, so equivalent circuit of this one, what will be there? You have to remove this capacitor short circuit. Okay, you have this now your V naught. Okay, this is also become short circuit capacitor, so you have a V1 now. Okay, now let me make the simplified circuit first. You have a V input. Okay, I naught current is coming here, I naught. So I naught coming here, resistance R1 and R2. I'm directly writing now this R dash. Okay, with no issue because both are parallel, we know. And this is your, this will be replaced by a resistance beta RE. Okay, and this will be replaced by, say, a resistance beta RE. Okay, now before that, now there is slightly modification. Okay, let me draw that one. Okay, so beta RE, this resistance is beta RE, very good. Okay, no issue. Okay, and then you have here RE, this RE coming to here. Okay, but now this time you have this circuit also here, because this is not now not going in the ground. If it is going in the ground, I can directly make it ground. Okay, this ground and this ground, but this RE is there. Now this beta IB will not be in ground. Okay, so this is your beta IB, and here you have R naught, you have RC, okay, and I naught current is in RC. This is beta IB current. Okay, rest is everything same. Okay, now this is your equivalent circuit. Baki, now rest is same what you're doing. You want to calculate input impedance ZI. Okay, there will be no change, but now this resistance will change. This resistance I call ZB. Okay, where your ZB is equals to beta RE, and here current is IE. Okay, here current is IE, which is again beta IB, which is beta IB current. So I can write this R instead of RE, I can write what? Beta RE. So this is beta RE. Either you write beta plus 1 RE, either you write IE. Okay, let me try to, this is IE. So IE is beta 1 plus IB. Okay. So now my resistance will become beta plus 1 Re, beta plus 1 Re. So this is the exact expression for ZB. Now if you want, you can also write beta Re plus Re if you neglect 1. Okay. So now this time my resistance will become R dash parallel to, if I want to make input impedance, then you have to open this one. Once you open this one, this is separated, and input you have a one resistance, this one, and this become parallel. Okay, this end and this whole will become parallel, ZB. So this will be your input impedance in this case, ZB, where you can write ZB is your nothing almost equals to beta Re plus Re. Okay, and if Re is greater than Re, then you can also neglect this one. So you can write R dash is equals to beta capital Re this time if your Re is greater than small Re. So this will be your Z1 this time.
सर ये आपने क्या बोला, मतलब ये पैरेलल में चला जाएगा ब्रांच?
पैरेलल तो है ना भी अगर ये यहाँ पर करंट नहीं है, ये ओपन हो गया, in order to calculate input impedance you have to make all the circuit open, shut off. तो ये ओपन हो गया, अब तो यहाँ करंट कुछ है ही नहीं, तो अब जो करंट यहाँ आ रहा है वही करंट यहाँ आ रहा है, बीटा आई भी करंट यहाँ आ रहा है. ठीक है,
यस सर,
बस वही हो गया. अब तो ये दोनों सीरीज में हो गए, and then this become parallel.
यस.
Okay, and again I'm adding this one here. So now let us calculate your Z0 and other parameters. Okay, so Z0 will be what? Z0 will be your, this time open this one, again they are parallel, so Z0 will not change. So Z0 is your R0 RC. If R0 is greater than RC, so I can write Z0 only RC. Okay, and now AV will change. Okay, V output will change. I want V output, that will be minus I0 RC. Okay, so let us now find out what is your I0 RC. This will be same. Okay, let us check what is the same, what will change. Okay, so your AV should be I0 RC. Okay, so
Beta IB.
It will be beta IB into R0 upon
IB.
R0
so,
plus RC.
so I0 I can write same like what you written, R0 parallel to RC
RC.
and beta IB. Okay, beta IB. Am I correct? Okay.
Yes.
Yes, sir.
And now V input change this time. V input will be what? V input will be now IB. Now this is V input. This whole is like same. This voltage equal to this voltage. So,
IB into beta RB.
IB into, so I am taking this combination. So beta IB RE plus RE. Okay. So now calculate AV. So AV will be minus beta IB. So this will cancel beta IB. So I'm directly writing this will be R0 RE, and this will be R0 RC. R0 RC or R0 RC. And this will be your RE plus RE. Okay. And now if R0 is greater than RC and RE also greater than your RE. Okay. In that case, what you can write? You can write this simply, this one as a RC minus RC by RE. This is your AV minus RC by RE. This time to change because of the resistance RE. पहले क्या आ रहा था? So this is your RC by RE. Okay. Now current gain. Okay. Current gain I want to tell you. पहले क्या आया था? Small RE आया था ना?
हाँ, small.
Capital RE आ गया. Now I will give you the एक general explanation for current gain. that you can apply in any circuit. Okay, सोचने की जरूरत नहीं है कि कौन सा सर्किट है. We'll drive now a general expression for current gain. If you know the voltage gain and input impedance, you can directly calculate the current gain. Okay, before that we'll calculate the current gain here. So current gain is, I want my output current. Output current will be, क्या होगा output current बताओ?
Beta IB
Beta IB
R naught
R naught.
upon R
R.
naught plus RC.
Very good. Beta IB, and I input will be what? I input is this one.
I beta.
Huh? What should I write? I beta.
Yes, sir.
I input.
I beta.
I beta. Beta.
I
Beta IB, yeah? Sure. I input. How can I write beta RB now? Tell me. So IB, this is only IB, na? Here only is IB. Or how can I come beta RB? Tell me. कौन बताएगा क्या आएगा?
It is IB, sir.
Only IB की beta, only IB or beta IB?
IB.
IB, why are you saying beta IB? Okay. So IB then tell me. I naught R dash. So this is R dash plus what? This total resistance, yes or no? ZB.
ZB plus RB.
नीचे क्या आएगा? R dash. नीचे क्या आएगा? R dash. Yes or no? You can भी अगर IB निकालना है तो मैं लूंगा सामने वाला रेजिस्टेंस and sum of resistance dash plus ZB. ठीक है? So it's okay. Now I want AC. तो AC क्या हो जाएगा? IB कैंसिल हो जाएगा. बीटा into R naught plus RC. Okay, and then you have here R dash plus ZB. Okay. Yes or no? Okay. So again, if R naught is greater than RC and your R dash is greater than ZB, then your AC will come again beta. Okay, let me check whether it's coming or not like this. So beta RB RZ RB plus RB RZ. Okay, is correct. Okay. So generally your R naught is infinite. Okay. So I'm not taking all the approximation now. Okay. So generally only R naught is very high. This we don't know. Okay. This is what maybe comparable. Okay. So I'm taking R naught is very greater than RC. So this time what I get the expression for current, that is R naught cancel. You have a R dash and R dash plus ZB. Now this expression is very important. Now this expression I can modify a little bit. Okay. So let us now all the things are calculations over. So I can love this one. So let me remove this one, everything. Okay. Now you need to tell me what is the expression for ZI. Tell me what is the expression for ZI. Tell me. Keeping R not infinite. What is the expression of ZI? ZI is what? R dash parallel
to ZB.
That's not enough. That is ZB R dash ZB small or capital, whatever you have. Okay. So this is ZI. Okay. And here we have a R dash upon R dash plus ZB. Okay. So let us modify this one. So from here, I can find the value of R dash upon R dash plus ZB. I can write ZI upon ZB. Okay. Put this value here. So this will become ZI upon ZB. Okay. And okay. And ZI is what? This is ZI upon beta RE plus RE. Okay. So I can write RE is greater than RE. So I can modify this as a beta ZI upon beta RE. Okay. So this beta cancel. So you have a current gain equals to ZI upon RE. Okay. Now tell me what was the voltage gain? Voltage gain. If I take my R naught is greater than. So my voltage gain was what? It was RC upon RE. Yes or no? My voltage gain was
Yes, sir.
okay.
Yes, sir.
Okay. So now just put this from here RE value. So my RE value will be now what? Minus RC upon AV, and that value you put here. So if you put that values here, okay, you get now your AC. What AC? I want prime
Minus
AC.
divided AV upon RC.
तो ऐसा ही हो जाएगा, मेरा कितना हो जाएगा बताओ? AV minus
divided
AV ZI upon RC. Okay, this is the general expression for any circuit, any transistor circuit, AC analysis. You can put approximately answer will come same. If you forget how to calculate current gain, you're not able to find the circuit, just put this formula. Okay. AV you should know, input impedance should know, RC should you know, put this value, this is almost accurate value will give any circuit. Okay. So you can solve the questions and you can find yourself that it will give you almost same values always. Okay. Now let me do some exam problems. How much time is there? Time is there. Okay. Now there are many type of biasing. Okay, but the method is same. Okay, we cannot. There are 10-15 type of biasing. We cannot do that in class here. Okay, but the method I told you that is similar. Okay, you try that method and try to solve. And the best book for this is Ball State. Okay, Ball State book for electronic devices. You practice these questions from that book. Only RE model. Okay, you have to practice DC biasing, DC circuits, or biasings, and RE model from that this book.
Sir, STEND और AD
क्या चीज?
स्पेलिंग क्या लिखा है?
बॉल स्टेट की बुक तो फेमस बुक है, तुम्हारे पास बॉल स्टेट की बुक नहीं है अभी तक?
नहीं सर,
बॉल स्टेट की बुक तुम्हारे पास होनी चाहिए ना? उसमें हमारे उसमें ड्राइव में पड़ी हुई है, मैं कितनी बार तो शेयर कर चुका हूँ. So everyone please solve the questions of this transistor. Transistor के लिए और कुछ नहीं देखना है. You have to see this Ball State book. Okay. If not there, I will send today. I will send after the class again one more time. So let me solve some problem from exam. So this is your GATE 2017 problem. Okay. बड़ा simple questions ही आते हैं इस exam में. This is your R1 is given and VCC is given, and then you have given R2, and then is given R3, and there is given V input. Okay. Now R1 value is 10 kilo ohm, R2 value is 10 kilo ohm, R3 value is 1 kilo ohm, beta value is 99. They are asking what is the value of ZI? Neglecting. Okay. Ammeter base junction resistance. Ammeter base junction resistance. Okay. Ammeter base junction resistance क्या होता है बताओ? अमीटर बेस जंक्शन रेजिस्टेंस क्या होता है?
डायोड का आरई,
RE, very good.
स्मॉल
This is
आरई।
RE. They're saying neglect this resistance and tell what is the Z impedance. Okay, so you don't need to calculate, add this one here. Okay, now what will be the equivalent circuit? This one, make the equivalent circuit and do please calculate how much is coming your input impedance. So let it remove this one. Okay, now simplified circuit will be, this is V input, this will be your R1, this will be your R2. Okay, and now here what will become? Beta RE like this.
डाउन हो जाएगा ना।
So you have RE and here, because RE is there, so you cannot make separate this one. Okay, so this is this one. Beta RE also there, you can put, that is negligible. Okay, so here beta RE also there, but we are neglecting this one. Okay, and you are neglect this resistance, so you have to put resistance 0, so no issue. So we don't have any problem. Okay, IB current is coming here. Okay, and IC current is coming here, that is beta IB. Okay, and IB plus IC, IE current is coming here, that is beta plus 1, IB current is coming here. Okay, and other things in the question, other things we don't need. Okay, because RC everything we don't need. They are just asking what is the input impedance, what is the input impedance here, what is the input current. Okay, so okay, so this IC is coming here. Okay, the input resistance will be what? Simply you need to open this one. Okay, so what is the formula for input resistance? Tell me now in this question. Anyone?
I1
R1 parallel to R2.
R2
That will be
R2 RE parallel.
very good. Now parallel is not RE, because the current is IB, so this is beta RE, beta plus 1 RE,
Beta into RE.
beta plus RE. Okay, because you have to keep the, if it is input, you have to keep the current same. Okay, I'm writing, let it write IB, and this, and replace this RE by beta plus 1 RE, beta plus 1 RE. Okay, calculate what is coming now, value R1 R2 beta plus beta, everything I given you. Tell me what is the answer.
$4.7 kilo.
Is coming 4.9. I have answer 4.76 kilo. Yes, 4.76 kilo. 4.76 kilo. Someone else also confirm. Okay. So let me do one more problem. किसी को कोई डाउट है रहा है क्या क्वेश्चन करने में? If you finding any difficulties doing these questions, anyone is there? Okay. Because I feel this is very simple. Okay, once you make them, if you know how to make the circuit, then it is very simple calculations. Okay, almost all the questions are follows
कितना आ रहा है सर आंसर?
4.76.
4.99
4.99 लिखो जो भी आ रहा है. 4.99 भी मेरे पास 4.99 नहीं एक्चुअली आंसर. 4.99 है मेरे पास.
4.99 आ रहा है।
हाँ, और भी तुम्हारा कितना आ रहा है? Not there. Anyone else? Bulela? Now you have next you have a VCC. VCC is your 20 volt. 20 volt, okay. And you have this one 2.2 kilo ohm. Okay. You have here RB. So let me say, sorry, I have taken wrong problem. I want to take different problem. Okay. This is your 2.2 kilo ohm. Here we have capacitor, sorry, transistor here, and here is RE, and RE value is 0.68 kilo ohm. Okay, and you have here 90 kilo ohm. Okay, IB is going here. You have a capacitor C1 here. We input here, and this is your 10 kilo ohm. And this is your V output. So solve this circuit. Okay, so this is you take 16. Okay, VC is how much? VC you take 16. 16 volt. Let me check whether VC is 16 or not. VC is V upon RE. VB is 100. Okay, correct. This is 16 volt. So first you do perform the DC analysis and tell me what you're getting. What you're getting the value of RE. Tell me what is RE value is coming. Okay. First you need to calculate what is IE in the circuit. IE. And in order to calculate IE, you can do approximation method. And the approximation method says neglect this IB and find the voltage here. So for first step is you have to do DC analysis, make it open. Once you make it DC, this will be open. This will be also open. Okay, remove AC. First you do DC only. Okay, and calculate IE. First you find this VB. This VB is 0.7. Once you know the VB, you can find VE. Okay. And once you know the VE, you can easily find IE. Okay. So IC is there. Current I is coming here. So first find VB. What is VB? What is the value of VB? 100 upon 16 upon 100 into 10. How much? (16 upon 100) VCC upon R1 plus R2. Approximation method IB 0. So whole current is coming here. The voltage across 10 kilo ohm, that is your R2. VC is 16. R1 is 90. 100 kilo ohm into 10 kilo ohm. Cancel. 1.6 volt. Okay. Once you know the VB, you can find VE. VE is what? कितना आएगा? 1.6 VB minus VBE. Yes or no? This VB will be loss between here and here. This VB is equal to this VBE plus this VE. Okay. So your VB 1.6 minus 0.7. That is comes out 0.9 volt. Okay. And once you have a 0.9 volt, you can find IE. IE is VE upon RE. That is 0.9 volt divided by RE is 0.68 kilo ohm. 0.68 kilo ohm. So how much is coming? Tell me.
(1.324)
Okay.
milliampere. 1.323.
324.
324. 3 to 4 milliampere.
Someone else also confirm, please. Okay. So you know the IE, now you can find RE. Okay, RE will be 26 millivolt divided by 1.324 milliampere. Okay, and this I have 19 point something, 19.637, 19.637 ohm.
19.637 ohm.
637 ohm. So now you got RE. Okay, now please find out what I'm telling. You need to find out ZI, Z0, AB, and AC. Okay. This circuit I already solved, so you can directly use the formula. And if you want, you can take R0 infinite. Okay, you can take R0 infinite. And beta value, you also need beta value, no? So take R0 infinite, and beta value you can take in the circuit 210. Okay. And just tell me what is Z impedance approximately. So the formula for Z input, what is the formula for this one? R dash parallel to ZB, okay, and R dash, okay, you can write R dash into ZB is your beta. You can write beta RE plus. You can take this approximation. If this is very less, you can neglect. So this is ohm and that is kilo ohm. So you can neglect. I think 600. You can neglect this one. Okay, and then you have a R dash plus ZB, that is beta RE plus RE. Okay, so I am giving the approximate answer. I have 8.4.
सर आप RE डायोड रेजिस्टर निगलेक्ट करें ना हम
चाहो तो कर दो, क्योंकि ये तो किलो ओम है ना, ये 0.646 किलो ओम है, 680 ओम, and this is only 20 ohm. So if you want you can neglect. अदरवाइज फॉर्मूला सही है, निकाल के देखो कितना आ रहा है. मेरे पास अप्रोक्सीमेट आंसर ये 8.4 आएगा, तुम्हारा कुछ और आएगा, 8.4 समथिंग आएगा. So I am not removing this, let it be there. ध्यान कितना आ रहा है? Anyone solving or not solving? कोई सॉल्व नहीं कर रहा तो चेक कर लेना अपने आप करके, ठीक है. How much is coming? Okay, so
स्क्रीन फ्रीज हो गई थी
okay, so let us say this is 8.4 coming. Okay, now the next is your Z0. Z0 equals to what? Z0 कितना होगा? R0 RC.
parallel to RC.
R0 is infinite. This will be only equal to RC. What is the value of RC? 2.2 kilo ohm. 2.2 kilo ohm because R naught is infinite. What will the value of AV? Tell me, if R naught is infinite, what is the value of AV? RC by R.
0.23.
AV कितना आ रहा है?
-3.23.
Very good. Minus 3.24. 3 something. 3.24, na? 3.24 or something. If you neglect this one, there will be something change. Very good. Now just tell me last. You have AB, you have ZI, you have RC. So you can use the formula for AI what I given you today's class. So AI is what? Minus AB, ZI, RC, and tell me what is AI value. No, AI value should match with what value? The beta what we have calculated here. Let us say, let's see whether it is matching or not. What is your ZI? ZI, how much ZI? 8. ZI was 8, na? Almost 8.4. Okay.
8.4.
And AB is minus 3.24. Okay. And RC is what? What is RC? So AI will not come because RC
2.2.
2.2. Okay. So how much is coming?
12.468 into 10
Yeah,
to 3
12.47. Okay. Correct.
Yes, sir.
is to 3 na?
हाँ जो भी है almost 12 आएगा. Okay. So here beta value is 210. Okay. Why AI coming so less? That means for approximation what we need, if we need to come to beta, what are the approximation? So approximation for here, if you want to make beta equals to, then approximation is your RB should be greater than ZB. R dash should be greater than the ZB. So R dash here, R dash is here. So in our question, our R dash is not
Sir, you're not audible.
Voice नहीं आ रही.
सबको नहीं सुनाई दे रहा है ना?
Yes.
R dash value is what in that one?
Sir, voice कट रहा है आपका.
So I'm saying what is the value of R dash? R dash is 9.
Voice जा रहा है.
Well,
Sir, you're not audible, sir.
okay.
सर आपने क्या बोला वो कुछ सुनाई नहीं होती है बीच में.
R dash कितना आ रहा है? 9 किलो आ रहा है ना? ठीक है. और ZB कितना आ रहा है बताओ? What is the value of ZB? What is the value of ZB? ZB is your beta RE. How much is coming? This 210 into 0.68 kilo ohm. Yes or no?
Yes, sir.
That means this R dash should be greater than this one. Then only you can do approximation. But this is not true here. How much is coming? Tell me. How much kilo ohm coming? Calculate. How much kilo ohm coming ZB? Tell me.
142.8. 142.8.
8 kilo ohm. Okay.
Hmm.
So basically your ZB is greater than R dash. Okay. So that is why your gain is coming less. Okay. So that's what in this chapter. Okay. So I'm stopping here now. So to next class onwards, we will start your operational amplifier. Okay.
तब सर अप्रोक्सीमेशन हम ZI का नहीं कर सकते ना, हमें वैल्यू सारी सब्स्टिट्यूट करनी पड़ेगी।
हाँ करनी पड़ेगी, करनी पड़ेगी। और उल्टा भी है, मतलब अगर आप बीटा के बराबर चाहिए तो आपका R डैश बड़ा होना चाहिए आपके ZB से। ओके, यहाँ पे उल्टा है।
ZB से बड़ा होना चाहिए।
That you see in that approximation when we do for beta ना approximation, that time what we do.
ओके, और सर वो जनरलाइज फॉर्मूला वैलिड होगा क्या?
हाँ वो तो वैलिड है, आप वैसे भी निकाल के, आप चाहो तो वैसे निकाल के देख लो।
ओके,
आएगा, सेम ही आएगा। ओके, so next class we'll see op-amp. Okay, any question? I'm stopping here. Please do practice the book, Bolstead book. I'm sending once again. Okay, and you do the problems from this book. Thank you.
Thank you, sir.
थैंक यू।
Thank you.